In this video, we will be looking at two-step unit conversions. So let's get started. So you've already learned how to count atoms. You've learned about the mole, how to find molar mass, and how to do one-step unit conversions. So today we're actually going to do unit conversions again, but this time they're going to have two steps, and we're going to convert from either grams to atoms or molecules, or atoms or molecules to grams. Here is the chart from the first video. So it tells us what happens as we move from atoms to moles and from moles to grams and vice versa. Before, we were only looking at one of these steps and applying it. So today, we're just going to be looking at the entire process. So grams to moles to molecules, or molecules to moles to grams. We will first start with grams to either atoms or molecules. And in this case, it says how many atoms are in 7.66 grams of potassium. So I'm going to draw a table. Here it is. And let's go ahead and write down the piece of information we were given in the problem. 7.66 grams. Here it is. So let's write it here. And remember, nothing goes in this bottom part. So since we started with grams, we're starting here in this section, which means we need to move to moles. To do that, we have to divide by molar mass. So we're going to need the mass of potassium, K. Again, you learned how to do that in a previous video. So from the periodic table, we see that potassium's mass is 39.1 grams per mole. Let's go ahead and apply this. So it says divide by molar mass. So that means in this step, we're going to divide by the 39.1, and that's 39.1 grams per mole. So 1 mole goes on top. Step 2. We now made it to moles, and we need to move to atoms/molecules. So we're going to multiply by Avogadro's number. As a reminder, this is Avogadro's number. So since we're multiplying by Avogadro's number, in this step, that means Avogadro's number, which is 6.02 times 10 to the 23, will go on top. And in the bottom, we know that's equal to 1 mole, so we add 1 mole. To see what this equals, let's put it in the calculator. And when you do, you're going to multiply everything on the top together and then divide by anything you see on the bottom. The ones will cancel out, so we can ignore those. So 7.66 multiplied by Avogadro's number divided by 39.1 gives us 1.18 times 10 to the 23rd atoms of potassium. In the next problem, we're looking at atoms or molecules to grams. So how many grams are present in 8.76 times 10 to the 24th molecules of carbon dioxide? Here's our table. And we're going to take what we were given in the problem and write it in this upper left-hand corner, leaving this bottom part blank. So this time we started with molecules. So we're starting up here, and we're going to go molecules to moles to grams. So to do this, we're going to need to divide by Avogadro's number this time because we're moving from atoms or molecules, so molecules to moles. So in this step, we're going to be dividing by Avogadro's number. Avogadro's number is here, and we're dividing by it, so it's going to go in this bottom section. And in the top, we put 1 mole because this many molecules of CO2 is equal to 1 mole of CO2. In the next step, we've gone from molecules to moles, and now we're going moles to grams. And we see we're going to be multiplying by molar mass. So we need the molar mass of CO2. Since you've already learned how to do this, I'm just going to give it to you. So here is how we calculate it, and when you add that together, we would find 44 grams per mole. So let's do our multiplication. In this last step, we're going to be multiplying, so it goes on top, and that's per 1 mole. It equals, remember, we're multiplying by everything on the top and dividing by anything we see on the bottom. So 8.76 times 10 to the 24th times 44 divided by Avogadro's number. And if you ever see that I put parentheses, make sure you're using those parentheses in your calculator as well. That'll help to avoid any calculator errors. You should find the answer to be 640 grams of CO2. I added this decimal so that this would be 3 significant figures to match what we began with in the original problem. So for this one, How many molecules are in 124.980 grams of iron 3 bromide, which is FeBr3? I wrote it for you. Go ahead and pause this video so you can try it on your own and press play when you're ready or if you get stuck. Okay, so I'm just going to go through this very quickly. We take this and put it in the upper left-hand corner. Don't write anything here. We're following our steps over on this side. We know this is the molar mass, so we're going to divide by molar mass out of 1 mole. Step 2, so we're moving this way. Multiply by Avogadro's number. Here's Avogadro's number. Plug it in. It equals 2.55 times 10 to the 23rd molecules of FeBr3. And finally, here's the last problem. So again, right here, go ahead and pause this and try it on your own. And we're going through this one quickly as well. So we're taking this, putting it here so y'all can check your work. Dividing by Avogadro's number. Then we multiply by molar mass. The molar mass of NaCl can be calculated like this. And it equals 9.6 times 10 to the 6th grams of NaCl. So now you should be able to calculate or do two-step unit conversions. Thanks for watching.